The broadcast is now starting. All attendees are in listen-only mode.
All right, well, it's 1 o'clock. We'll go ahead and get started. So thanks everybody for attending our webinar, focusing on respiratory protection, what goes into the selection, the limitations, and fit testing, so everybody can understand how to run a safe respiratory program. So a little bit about myself and Bullard. Bullard is a manufacturer of a wide range of PPE products. Bullard is actually the inventor of hard hats, and we also were on the front cutting edge of blast respirators. So both of those products helped build the Golden Gate Bridge project, and we've been providing protection for the Golden Gate Bridge ever since. Bullard provides and manufactures PAPR respiratory systems as well as supplied air respiratory systems for both life science and industrial users. But today, with the help of FACS, industrial hygiene safety organization. They support the U.S. nationwide. We both share, a common interest of just educating end users with how to work safely through their day and make sure that the PPE they're wearing is providing enough protection and is actually helping to increase their work life and their productivity. So today you'll be able to hear from Sylvia. She's a certified industrial hygienist, and she travels the U.S. working with different clients around in all different states. She has 39 years of experience working in industrial hygiene. Sylvia has worked with Bullard on several other webinars. You can visit our website to access all of those. But we're really excited to hear everything, all her expertise that she brings to respiratory safety. So throughout the webinar, we're going to have a series of poll questions, and here are the instructions on how to participate with that. If you have any questions, there are the instructions for polling. If you have any questions along the way, please select that chat feature, and you can type your questions for us, and we'll get those answered at the end of the webinar. And if you need a certificate that stated that you attended the webinar, just go ahead and reach out to us and we can provide that document back to you.
Okay, thanks, Patrick. I think I will take it from here. As you can see, everyone, welcome. We're glad you're all here to join us. We're going to talk about respiratory protection today. And you can see here, we're going to best practices, mainly concentrating on respiratory selection, the various types of respirators that are available, that type of information. We're not really going to go into regulations today, as our fourth quarter webinar that we're joining with Bullard on will be about the respiratory regulations. So we're going to concentrate on use and selection today. I think most of you have probably seen this hierarchy of controls, and this is what we go by when we're trying to reduce chemical exposure, any type of exposure to workers when they're in the field. We always want to start at the top. We want to try and eliminate the hazard to the extent that we can possibly eliminate it. We can substitute potentially some chemicals. Maybe we could take a toxic chemical out of the workplace and provide something that's less toxic, maybe doesn't evaporate as easily, maybe something that doesn't absorb through the skin and cause illness. So if we can substitute, we would do that. Engineering controls come into play as well. We want to try and ensure, especially when we're talking about areas where we might need respirators, is it possible to put in some sort of local exhaust ventilation system where you can actually pull the contaminant away from the worker and eliminate it from the space so that they don't have to put respiratory protection on. That would be ideal. Administrative controls, there may be some things that we can do and maybe some moving people around in different spaces so they're not working as closely to where these chemicals might be. Would try that as well. And then an absolute last resort is to put on personal protective equipment. In this case, we're talking respiratory protection. So that definitely is the last resort, but sometimes it's absolutely necessary and we can't eliminate the health hazards enough to prevent the illnesses from occurring by using these other options, and we have to go into respiratory protection. So when is it required? If we have a toxic atmosphere, one thing we need to look at, here's some examples of areas where we might need to wear respirators. We've got asbestos abatement going on, blasting operations, as Patrick just talked about with the respirators they provide for the Golden Gate Bridge. Hazardous waste sites, definitely respiratory protection is needed. So you can see some of these examples here. So when the atmosphere is toxic, we consider it to be near or above the occupational exposure limit or the threshold limit value. So we want to be looking at that and determining what those thresholds are in our workplaces, maybe measuring what those atmospheres are, having an industrial hygienist come in and measure in the air what those concentrations are. And then we also look at confined space entry is one area where we might need to have respiratory protection if there's an oxygen deficient atmosphere in there or a toxic chemical in that confined space. So just some examples of where we might need to introduce respiratory protection. And we'll see other examples as we go through. But one of the main things is evaluating that atmosphere. Are we at or above the permissible exposure limit or the threshold limit value in our spaces, or do we have an oxygen deficient atmosphere or some sort of toxic atmosphere in our spaces? Let's make sure that we actually go in and measure those. So there's two different classes of respiratory protection. Air purifying respirators is the first class. These are respirators that they actually just filter the air that is going through the respirator. So you can see in this example for one of Bullard's respirators, the filter cartridge would actually go right in here and the air would go through it and filter the air. So you have to make sure you select the right filter, and we will be talking about that. So you create a negative pressure inside that face piece. It forces that air to go through the filter, and then it's theoretically clean air coming to the employee as they're breathing it in. So that is the first class of respiratory protection. The second is air supply respirators. These are actually providing you with breathing air. And you can see the first example here is a self-contained breathing apparatus. Most familiar with this, firefighters are going to wear this when they're going into a fire. This provides the breathing air on their back. They're going to carry that 30 minutes or 60 minutes of air that they can carry with them. The other type of atmosphere supplying respirator is an airline respirator where you're not actually carrying that air with you. You're actually hooked up by a high pressure hose to a bank of cylinders that are providing the grade D breathing air. So you can see an example of one of those respirators here. And we're going to talk in a little bit more detail about each of these classes of respirators. And then we're going to come upon our first poll question. So if you would take a look at this and put your answers into the chat, and then we will see what our responses are. The two major classes of respirators, self-contained breathing apparatus and supplied air, air supply and atmosphere supply, full face and half mask, or cartridge and canister. We'll give you all a second to come up with the answers. And they'll go ahead and give you the answer, see if you were right. So the answer, air purifying respirators and atmosphere supplying respirators are the two classes of respirators that we just talked about. All right. Hopefully we had some participation in there. Now, let's go into some details about the different types of air purifying respiratory protection. So we have our single-use, half full, and PAPRs are for the types of respiratory protection. So looking first at our single-use disposable respirator, an N95 is a perfect example of those. We've been seeing those for a couple of years now. They're everywhere. So these are considered single use, and unfortunately, when I go into manufacturing spaces, I see these hanging on equipment all the time. They're hanging from a pipe, they're hanging from a piece of equipment. They're filthy dirty, and people are putting them on and off all the time, which is not the appropriate way to be using your respirator. So you might use these if there's just some nuisance dust in the area. Maybe you're not over a permissible exposure limit or close to it. But it's just dusty and people don't really want to work in that dusty environment. You can have employees put on a single-use respirator in that type of an instance. And there are other situations where we might use them. They obviously were used during the pandemic, so they're good for some aerosols as well. And there's different types of single-use disposable respirators out there as well, not just the N95s. And they do each have a specific purpose, and we'll see that in a little bit. We have half-face air purifying respirators. So these cover the nose and mouth. They have the filters on them, as you can see. So we're forcing air through both filters into the nose-mouth area. These provide some additional protection over the single-use respirator. They are fitted to the employee. When you are fit testing for your respirators, you do need to have multiple options for respirators. Every brand, every model has a different shape and multiple sizes. So you have to have options for your employees to make sure that you find one that fits them appropriately. So these work well in areas where you don't need eye protection and you just need minimal protection for protecting the respiratory system. Then we go to full face respirators. So these provide additional protection. They seal better around your face because they're going through like kind of the outside of your face as opposed to just around the nose and mouth, which is much harder to fit those spaces. So you do have additional protection here. And it is a filtering respirator, so we do put the filters on the sides of this respirator, but it also provides eye protection. So if you're in a situation where the employee needs to have eye protection in addition to respiratory protection, often it's just much better to go into a full face respirator instead of a half face respirator and safety glasses or chemical protective goggles or something of that sort. It's just much easier sometimes to wear that full face respirator. And then if the concentration of the contaminant in your space is higher than what the half face respirator will accommodate, then you can go into the full face respirator as well. And then we have air purifying respirators or powered air purifying respirators. These have a little battery operation that you wear, battery operated that you wear around your waist. The battery actually pulls the air through the filter and pushes it into the face piece. These have some advantages. They're much easier on your respiratory and cardiovascular system. The other 3 types that I showed you do put significant strain on your respiratory system and your cardiovascular system because you're creating that negative pressure inside there. And that's just much harder on your system. This is actually a positive pressure. It's pushing air in, so you're not creating a negative pressure. Much easier on your system to wear. Gives you a good protection factor, which we'll talk about. And again, filter options for these. You can see just 2 of the options available, and there are many others available for these. You can also wear these if you have employees who are not able to shave. All the others require no beards, no facial hair in the seal. This one you can wear for people who do have a beard and they're not able to shave, and there are people with medical reasons to be unable to shave. We've come across that. We've had to provide options for those employees who, for medical reasons, are not able to shave. So this is a good option there as well. Then going to the atmosphere supplying respirator, the self-contained breathing apparatus. It is a full face respirator fitted to the face just like the other full face respirator, but your breathing air is contained on your back. You're going to carry this with you. These are good in areas where the concentrations are higher. Like I said earlier, firefighters will use these. We might use these to go into a confined space if we don't have to be in that space for very long. The tanks can have somewhere between 30 to 60 minutes worth of air. Often you get much less. The person's working hard, breathing harder, they might go through the air in the tank much faster than what it's designed for. So you do have to watch out for that and have them be able to come out and switch tanks if that's necessary. So using these in those spaces with higher concentrations where there might be issues with having the air purifying, low oxygen concentrations, you can have this types of thing or higher toxicity in the atmosphere. Then we have the airline respirator, similar to the self-contained breathing apparatus. We have, we're supplying air, and you can see in this particular one where we have the breathing air in the cylinders. Usually there's a bank of cylinders or air that's just being filtered that is delivered to the face piece, and you've got the high pressure hose that it's going through. And you can have up to 300 feet of this high pressure hose. This is really good for long-term projects where you're not just going in and out in 30 minutes into a space where you have to work potentially all day long. We find this sometimes in the coatings industry and other areas where they're removing paint or putting paint, adding paint in, where they have to wear it all day long. So we want to be able to provide them with an adequate amount of breathing air without having to change out cylinders every 20 minutes. We'd never get any work done. So the airline respirator certainly is very valuable in those situations. Knowledge check. What does the acronym SCBA stand for? Self-contained bottle asphyxiate, self-contained breathing apparatus, sorry case of binomial arithmetic, self-continence biopsy assessment. So go ahead and put your answers in the chat, and we'll give you the answers in just a moment. Okay, answer self-contained breathing apparatus. So B would be your answer. All right, let's move on. Assigned protection factors. I've alluded to this a little bit. When you're choosing what respirator you need to have your employees wear, we're looking at the atmosphere, we're looking at what types of chemicals are in that atmosphere and what those concentrations are. The protection factors, as you see here, half-face respirator gives you a 10. This means you can wear a half-face air purifying respirator in an atmosphere where the concentration of the contaminant is up to 10 times the permissible exposure limit. So if your permissible exposure limit is 1, then we could go up to 10. If your permissible exposure limit is 2, we can go up to 20, so it's 20 times. Full face air purifying respirator, protection factor of 50, so 50 times the occupational exposure limit. PAPR, half mask, 25. The loose fitting face piece that we saw in the picture is a 25. PAPR with the tight fitting full face respirator gives you a protection factor of 1,000. And then you can see airline is 1,000 and the self-contained breathing apparatus is 10,000. So this is something you need to look at when you are choosing your respirator, so that you can determine, one, you determine what that toxicity is in the atmosphere, what that concentration is, and then we can select the respirator based on that. If we're upwards of 50 times the permissible exposure limit, we're going to have to go into a PAPR full mask, airline, or self-contained breathing apparatus. If we're around 4 or 5 times the permissible exposure limit, we can go into a half mask respirator. So that does have a determination in which one we're going to choose. The maximum use concentration is something that we try and calculate when we do exposure assessments to determine the concentration and what respirators people are going to use. It's the maximum concentration an employee can be expected to be protected from when wearing the respirator. So you determine that by multiplying the assigned protection factor, which you saw on the previous slide, by the occupational exposure limit. So whether you're using the OSHA permissible exposure limit, the threshold limit value, some have short-term exposure limits or ceiling limits, you multiply that assigned protection factor by that occupational exposure limit. And here's an example for us. An employee will be working an 8-hour shift on an active hazardous waste site. The expected average benzene concentration will be 40 parts per million. At what minimum respirator type is required to meet that concentration? So if you look at the calculation here, the assigned protection factor for a half is 10 times the threshold limit value is 1. So we can go up to 10 parts per million. But we've already said that the atmosphere is at 40 parts per million of benzene. So we can't use that one. The full face respirator, the protection factor times the threshold limit value, so 50 times 100, we can get to 50. That's greater than the 40 parts per million we have in the atmosphere. So we can go into a full face respirator in this particular situation. The employee would be well protected in this particular case. When can an atmosphere be used? Supplying respirator, you have to have an adequate oxygen concentration in your space in order to use an air purifying respirator. So greater than 19.5%. If the atmosphere is within the respirator's maximum use concentration, then you can use it as we just calculated, and we cannot use an air purifying respirator in an atmosphere that's immediately dangerous to life and health. And what that means is if you go into that atmosphere with no protection, you have less than 5 minutes before that atmosphere is fatal. We can't use an air purifying respirator in that situation no matter what. We have to make sure that we're using an air atmosphere supplying respirator. All right, let's do another knowledge check. Air purifying respirators can only be used if the oxygen concentration is greater than or equal to 20.9, 20, 19.5, or 20.5. Go ahead and put your answers in the chat. Give you just a few seconds. And the answer is 19.5%. So the answer was C. Let's hope everyone got that one right. All right. Looking at how these work. We can see particulates for air purifying respirators. So these filter the atmosphere. So the particulate filter dusts, fibers, aerosols, mists, and fumes. They have a filter cartridge that we put in, and they're made of various different types of paper that are porous material, just like more sophisticated version of your coffee filter or the cheesecloth that you use when you're cooking. More sophisticated, but it is paper. It's very porous. Liquids, vapors, gases will go through it. Particulates will be caught on the filter. And then as that filter gets more and more of these particulates on it, it will get filled up and become more difficult to breathe, at which point you know you have to change out your filter. They will also filter gases and vapors. So there's a sorbent part of that cartridge, typically has activated charcoal in it. What that does is it creates an enormous amount of surface area on that activated charcoal so that the contaminant can absorb onto that surface area. And when that gas or vapor uses up all of the surface area available in that activated charcoal, then you start to smell that contaminant coming through, and it's time to change out that filter at that point. So we've got two different parts of our filters. You can have just the filtering type of cartridge, or you can have just the sorbent, or you can have combinations of both. And I'm just showing you a lot of different examples of those two different kinds. And each of these is dependent, of course, on what is in the atmosphere where your employees need to work. Selecting the right type of particulate filter. Everyone's heard of the N95. It's everywhere. We've all heard about it, but that N has a meaning. It means not for oil. So you can have an N95, N99, N100, but you cannot use that in an atmosphere that has oil in it. So if you're in manufacturing and you have metalworking fluids and you have any other types of oils that are getting into the atmosphere, you don't want to use an N respirator. You want to use an R, which is restricted. It can be used in an oily environment for no more than 8 hours, which means you'd have to change that filter out at the end of the work shift. Or you can use the P95, 99, and P100 is the most popular, but most people don't know what that P means. P is oil proof. So it can be used in the atmosphere where there is oil in the atmosphere. It will still filter out the particulates. The oils in the atmosphere will not dissolve that filter, which is what may happen in these two, in the N and R. So most often people are just automatically going to the P100 is the most popular, but that's oil proof. So in manufacturing with those metalworking fluids and the other oils that might be in the atmosphere, the P type filters are the appropriate choice for you to wear. Another knowledge check, go ahead and put your answers into the chat. Which cartridge designation is considered a HEPA cartridge? So that's the old terminology for these. And let's see if you know what that is. All right, NP and R 100 is the answer. So good job, everybody, on that one. All right, now looking at the various cartridges that are available. So we've got the vapor cartridges, and how do they work? I already mentioned they have activated carbon or some other adsorbent, but most of them have activated carbon in them. The contaminant does adhere to the charcoal that's in there, and it is a limited surface area. Although it's an enormous amount of surface area, it is still limited. It's only what's available inside that cartridge, and then it's done. You do have to have a change out schedule if you are using one of the vapor cartridges so that you know when to change them out. So when do you do that? We'll be showing you a calculator for that a little bit later. But there's also just if you start breathing the material, the contaminant, and you can smell it, then you definitely have to change it out. Sometimes there's a taste associated with it, maybe a metallic taste depending on the chemical. Definitely change it out then. And you want to make sure you're storing these properly, because if you just toss that respirator with that cartridge sitting out in the workspace, it's going to continue to absorb some of the contaminants. You want to put it into a sealed plastic bag when you're not wearing it, so that you protect that cartridge, so that it's not continually filtering the contaminants and having them adsorb onto that space. All of these cartridges are color coded. So these are some examples of the color codes. I like these. I go into a manufacturing area, I can immediately tell what respirator cartridges people are wearing just by looking at the colors. Organic vapor is one of the most popular. It does what it says. It will absorb as a lot of different types of organic vapors. We have ammonia methylamine is this green color. The P100, this is the one that most people are familiar with, this magenta purple color, people call it. Technically, it's magenta. There's a olive color that's a multi-chemical, and you'd have to look up exactly which chemicals that it would work for. A white cartridge is acid gas, and then the yellow is the organic vapor and acid gas. So it's basically the black and the white together. Don't know how they came up with yellow. I would think they'd come up with a gray for that, but it's yellow for organic vapor and acid gas. And here's just another example of some others that we might see. There's a nice bright green that's an ammonia color. There's an olive and a brown together, organic vapors, ammonia, and acid gases. So you can see there's lots of different combinations of cartridges that you can use depending on the contaminants that you have in your space. And when we're out there doing an exposure assessment, we're determining what chemicals that you have in the atmosphere, how it relates to occupational exposure limits. We would tell you exactly which filters to put on your respirators so that you know which ones to wear. And then you can see there's lots of different combinations. I'm going to show you here some various combinations, some cartridges that you can see how they look with the different colors in them. Easy to tell what they are from a distance. This is a combination, the P100 with it looks like the black, the organic vapor cartridge. So various types of cartridges out there selected based on the contaminants that you have in your space. And then for the filtering respirators as well, color coded also. So the P100, various versions of this, as you saw over here, this is also the P100. And then here it just looks a little different because it's not in combination with another one. This is a P95 in combination with just a nuisance level organic vapor and acid gas. I wouldn't normally recommend wearing something like this. If there's organic vapors or acid gases in the atmosphere, I'd go to the other combination that I showed you earlier, where it's not just nuisance level. You can see here P100 in combination with organic vapor and acid gas, and then the P100 with the multi-gas combination on the bottom here. We have the combination with the organic vapor and a combination P100 and acid gas. So you can see that P100 is the absolute most popular that you're going to see in the workplace, and especially in combination with other types of cartridges as well. And then we have the Bullard breakthrough determination. This is their max life calculator. They use it for their EVA and eval PAPRs, the power air purifying respirators. So if you have this, if you have one of theirs, you can use this to determine at what point you should break through those cartridges. And you would need to know the permissible exposure limits and how much is in the atmosphere to put this in. I mean, many manufacturers have these breakthrough calculators for their respirators as well. So this is something that you can use to determine that change out schedule for your respirators. All right, let's look an ideal H atmosphere. Remember, immediately dangerous to life and health. We're not going to use an air purifying respirator in this situation. We're going to make sure that we're using an atmosphere supplying respirator. So either the SCBA or the airline respirator. You need grade D or E breathing air. Usually grade D is what's used. If you're going into an ideal H atmosphere, Your airline respirator, if it's being used, has to have a 5-minute escape bottle. These do come in handy if something happens to that respirator. I've had that happen to an employee when they were offloading literally a train car of chlorine into a building at a wastewater treatment facility. And they went in with their airline respirator, and that high pressure hose got a hole in it, and they had to use that escape bottle in order to get out of that building in time. And they made it out no problem. But if they didn't have that escape bottle, it would have been much, much more serious. So that is required in that ideal age atmosphere. Also, when selecting your respirators, you can't just go to Home Depot or Lowe's or Ace Hardware or any of these other stores and just pick out any respirator that's on the shelf. You need to make sure that they have been NIOSH certified. And you can tell that by looking, it's usually on the box of the respirator, and it has this TC number on it. So this one, TC84A0000, they all have a different number associated with them. That TC number says it's been tested and certified by the National Institute of Occupational Safety and Health to be able to do what the manufacturer says it will do in the workplace. There are respirators that are sold at a lot of our hardware stores that are not NIOSH certified. You can wear them at home if you want to. Still wouldn't recommend it if you're out in your workshop, out in your barn doing something. You can certainly have one of those other ones, but if you really want good protection, you'd have one that is TC certified. But this is the only kind that can come into the workplace. And I do often go into workplaces. I was just in one just a couple of weeks ago, cabinet full of respirators, and probably 3/4 of their respirators were not NIOSH certified, and they had to toss all of them. And they had spent a lot of money on those respirators, but they can't be in the workplace. They haven't been tested. We can't guarantee that they're going to work the way that they say they're going to work and protect your employees. And then we have just a little bit here on fit testing. Remember, every time somebody's wearing a respirator, they do need to be fit tested and medically evaluated. We have to make sure we fit test before they use them, and then at least annually after that. In between there, if somebody has an accident and they get a scar on their face where it's going to interfere with the seal, if they have some major dental work where maybe they lost some teeth, or they had some teeth pulled out and had dentures put in or something, those things affect the fit of the respirator. They should be asking for a new fit test at that point. There are two types of fit testing: qualitative, where we're just using an agent to see if they can smell it when it's coming through the filter. And then there's quantitative, if you truly need to know the exact protection factor provided for that employee in that particular respirator, then you go to quantitative fit testing, and that gives you a specific fit factor for that employee, as opposed to the general ones that I provided earlier for you. Knowledge check. Fit test is performed to ensure that the respirator is NIOSH approved, proper size and shape for the employee, the right style and color, or none of the above. Okay, and the answer: proper size, shape for the face, and proper seal is achieved. So good job, everyone. Now we could just go through a series of some pictures so we can talk a little bit about the respiratory selection here. This one is a situation, you can see the employee down here. This is actually what had been an abandoned sewer line that sat for a good 10 years at least. So the sediment in it had completely dried in, and I was called in because for various reasons, they knew there was sulfuric acid contamination in the sediment, and that's what they were concerned about and asked me about to protect them. So I wrote the plan for them to go in sulfuric acid, which really just initially was the suit, because we knew they were going to put a little water in here and then protect them from having the skin contamination from the sulfuric acid. Then I saw the site and I talked to the contractor and said, wait, you've got a much, much bigger problem on this particular project. As soon as you start putting water in here, you're going to get hydrogen sulfide methane and potentially low oxygen concentration. Because it's been abandoned, the sediment's been sitting there, there's going to be pockets of methane and hydrogen sulfide in this sediment. The contractor said, no, you're just here to look at the sulfuric acid. We don't need to worry about that. That's not going to be an issue. And I said, just appease me and put a 4-gas meter down there as you start putting the water in before you put your employee down in that space. So like, okay, well, within about 30 seconds, we pegged that meter. Hydrogen sulfide went up over 30 parts per million. The methane was at 100% and the oxygen went down to 16% because it was being displaced. So they immediately stopped. We regrouped, did what I had wanted to do, and ultimately when they were ready, we put the employee in self-contained breathing apparatus in this situation. Couldn't get him an airline respirator, and he didn't need to be down there for too long. So this protected him from that atmosphere. And after about an hour or two of the water going through here, we had churned up all those pockets and the atmosphere went down to where it needed to be. But we continued to have the employee in the self-contained breathing apparatus just in case another pocket of hydrogen sulfide or methane came through. So that's definitely one situation where you need that supplied air. Here's a coatings operation where they're using the chemical peel-away 7. This is a hazardous material. It has what we call N-methyl-2-pyrrolidone in it, and it is a skin absorption hazard, which I haven't spoken about, but that's something you need to protect your employees from as well. So in choosing this respirator, we had to go with a respirator that has an organic vapor cartridge in it. In this case, because they were using relatively small quantities in the space, the half-face respirator was enough to protect them from that contaminant, and then the chemical protective coveralls to protect their skin, along with the appropriate gloves to wear. There are situations in coatings operations where you go into full face or air supply respirator in many cases because of the contaminants when you're removing paint from water tanks or bridges and the like. You can see here a picture. We've got a lot of dust. He's grinding on some concrete. I don't think that N95 is appropriate, and he's certainly not wearing it properly. You can see where that yellow strap is. I don't think that's an adequate respirator for this situation. Should really be in at least a full face air purifying respirator for this particular situation. And probably in coveralls and misting the workspace as well, so that we can have some controls of that contaminated dust getting into the air, keeping it off his skin, so he doesn't have to take it home with him as well. Then we have something like this where they have to go in and refurbish these areas, this coatings operation. They're going to go in and they're going to blast these spaces and then repaint. Oftentimes, you can see the containments in there. During blasting operations, of course, you're going to wear a blasting hood with the supplied air going into that breathing space for you. Hazardous waste sites, we've talked about this a little bit. In this picture, it's only just one drum. I've been on many where they're super fun sites and it's just a sea of drums or a sea of liquid and we don't even know what it is. And we have to go into atmosphere supplying respirators, the SCBA or the airline respirators. So we can go in and determine what the contents of these drums might be. And there was something like this chemical use. Clearly, this person's going to be using a larger quantity of some of these chemicals. Went into a half-face respirator, chemical protective goggles, maybe he's wearing. I think I'd go into a full-face respirator in this situation, just to give adequate eye protection along with the respiratory protection as well. And I think that is it for our slides, and we'll see if there are questions for us from anyone while I was talking. Taylor's joined us.
Hey, Sylvia, we had a few questions come in. The first being, do persons performing fit testing, are they required to be properly trained by a recognized training organization?
There is not that type of a requirement. They do need to follow the regulation. There's a very specific procedure for fit testing in the OSHA regulation, where they have to go through a number of different exercises, 1 minute for each exercise, and it tells you exactly what equipment you need. You don't have to go through a training organization to train your employee, but it would be a really good idea to have a knowledgeable person train them. We often train our clients in how to do respirator fit testing as well. But yeah, it doesn't have to be a certified organization at all.
All right. Next question. How do you know the concentration of contaminants in the air?
So that's where you bring in your industrial hygienist, and we bring out equipment. We look at what your operation is, look at your safety data sheets. We determine what chemicals may be evaporating into the air based on that operation. And then we would actually test the concentration in the air for you. And that really is the only way that you can find out. You have to have someone come in and test to that atmosphere so you know what that concentration is. Compare it to the occupational exposure limits, and then in the recommendations tell you engineering controls or what type of respirator if there's no engineering controls or administrative controls that you can use. But you do have to do that testing.
All right. Next question we've got here. What options are there for communication while wearing a respirator?
So communication does get to be a little bit difficult when wearing a respirator. It is a little bit harder to hear when someone is talking. They do, if you're wearing a full face respirator or any of the atmosphere supplying respirators, they do have radio communication kind of that you can get to add into those, which will help for communication. Otherwise, you're also learning some sign language. Usually have some arm gestures and things to be able to communicate with people. But they do have built-in communication devices that you can get.
Great. And the final question as of yet, what do you do about respirators fogging when wearing them?
I'm sorry, what was that, Taylor?
What do you do about respirators that fog while you're wearing them?
Oh, when they're fogging, it helps to kind of pre-warm that face piece in the respirator, because usually that's cold and then you start breathing and it's warm. So if you're going to get it warm in advance, you can also get covers that are peelable, that you can peel off. They can go on the inside, so you can peel them off and change those out. And then there's a spray that you can put on them as well to prevent them from fogging. That's not toxic.
Great. And it looks like that's all the questions that we've got. If anybody has any other questions, put them in the question box there. But while we're waiting to see if any other come in, I know that there's this next slide that highlights the last of our 4-part series for 2024 is coming up in November, I believe, or December. I'm not quite sure if we've selected a date yet, but if you scan that QR code there, you can sign up to get notified when that, or automatically signed up when that 4th webinar is officially scheduled. So we'd love to see you there. And it doesn't look like there's any more questions that have come in. So I think you covered everything, Sylvia. But if you guys do have any other questions that come up following this webinar, please reach out. We will be sending out a copy of the slides, a copy of the recording of this webinar, along with our contact information for Bullard and Fax if you have any additional questions that come around. So thank you all for joining us. Thank you, Bullard. Thank you, Sylvia. And
Thank you.
Hope you have a great rest of your week. Thanks all.
Bye, everyone.